Okay, so 5.1, one-to-one and inverse functions. This would be day number 2. In day 2 video, you will see how to find inverses algebraically. Let's say we run into a situation where we're not sure of how to find the inverse just by simply doing the opposite. Well, okay, so if we're not sure, then what we can do is solve it algebraically, and that's kind of what we're going to do today. So I'm going to show you how to solve this algebraically, where there will be no question as to which one goes first. Okay, so the first one I did in 3 steps for you. It's the only time that I'm going to show you these 3 steps. From here on out, we're going to kind of just zip through it, but I wanted to kind of show you the steps that I take in order to find the inverse of a function. So first thing, in order to find the inverse of this function, I have to make sure that it's one-to-one. So my parent function, which is the cubed root of x, I know the cubed root of x. My parent function looks something like this. Okay, so I know it passes the vertical, I know it passes the horizontal line test. What does this positive 5 tells me? What does the positive 5 tell me? Well, it tells me that it's a horizontal shift to the left 5 units. So I know that I'm simply going to take this thing, I'm going to shift it left 5 units. It's still going to pass the vertical and horizontal line test. So I know an inverse exists. Please understand your parent functions, because looking at the graph is going to be the easiest way to determine if it's one-to-one. So now that it's one-to-one, I can find the inverse. Okay, so step 1, I'm going to replace the f of x with y equals. Okay, so there's that. I know to find the inverse, all I simply do is switch the x and the y values. So guess what? Step 2, switch your x and y. Okay, so it went from y equals to x equals. The x was on the inside, now the y is on the inside. So I've simply just replaced f of x with y equals in step 1. I switched the x and y in step 2. And now in step 3, all I'm going to do is solve for y. Okay, so here was my function that I had on the last screen. I know to get y by itself, the first thing I need to do is get rid of that cubed root. How do I get rid of that cubed root? Well, I'm going to cube both sides. Cube the left-hand side, cube the right-hand side. Think about it. What happens is this cube and this cube root cancel each other out, so I'm left with simply what's on the inside. And now the easy part, I'm just going to get y by itself by subtracting 5 on both sides to get y equals x cubed minus 5. And then I'm just going to write, okay, there is my inverse. So think, back at the original problem, I know it was adding 5 and taking the cubed root. What's the inverse or the opposite of that? Well, it's subtracting 5 and taking the cube. So kind of way that you can check yourself algebraically to see if you did this right. Do they match? Are they opposites of each other? And if they are, you're in good business. Okay, so let's try another one. So I ask you to use the algebraic method, so I want you to practice using your algebra skills to find the inverse of this function. Again, first step, determine if it is actually one-to-one. So I'm thinking it's the square root parent function. That thing looks something like this. I know that plus 2 on the inside simply means it's a horizontal shift left 2. So this thing right here is simply going to shift to the left 2, but it's still going to look like that. So it is one-to-one. Passes both the vertical and the horizontal line test, so I'm in business. Alright, so now let's find the inverse. How do I do that? Well, replace f of x with y equals. Switch the x and the y. Begin to solve for y. subtract 2. Voila, there is my inverse. I want to talk about this thing in class today. I'm not going to give you notes. I need to be face-to-face with you to kind of talk about why I needed to put that in there. Yeah, that's going to be interesting. It's going to be an interesting conversation. But notice, there is my inverse, but I had to write that x has to be greater than or equal to 0. We'll talk about that in class today. All right, one more. See if you can pause the video, give it a shot, try it on your own. All right, so first thing, switch the x and the y equals, switch the x and the y, solve for y, subtract 3. Voila, there is my inverse, and I am in business. Okay, so finding the inverse of a function algebraically should have been pretty simple. I'm guessing the only issue that you're going to run into is why the heck did I put that greater than or equal to 0? But we'll talk about that in class today, and fantastic job today.